So, hello students and welcome to our lesson. Today we're going to look at the factors affecting the equilibrium, and our first factor is concentration. So, we're going to see how altering the concentration of either the reactant or the product is going to affect the position of the equilibrium. I want us to consider a reaction between bromine and water to form our products here, the hypobromide, the bromide ion, and the hydrogen ion. So this is an equation of formation of the bromine water. So of course, bromine liquid is yellow, so our reactant solution initially should be yellow, and our products are colorless. So we're going to change the concentration of our hydrogen ions and see how that will affect the position of the equilibrium. So our first attempt, we're going to introduce sodium hydroxide into the system. So once we introduce sodium hydroxide into the system, then the sodium hydroxide will provide the hydroxide ions, the OH ions. So it's going to provide us with the OH ions. So we all know that the OH ions will easily react with the hydrogen ions. So we'll have OH ions plus the hydrogen ion, which will give us water. So by introducing sodium hydroxide, then it's like we are reducing the concentration of the hydrogen ions. So how will that affect the position of the equilibrium? So initially, before we introduced, that system was in a state of balance. But on adding sodium hydroxide, then hydrogen ions are being consumed. So the position of the equilibrium will therefore have to shift. And which side will it shift to? Because the hydrogen ions are reducing, then the forward reaction will be favored, so that it produces more hydrogen ions here. And so our solution will turn from yellow, our solution will tend to turn colorless, showing that the equilibrium has shifted to the right hand side. Next, I want us to introduce, now instead of reducing the concentration of hydrogen ions, then this time round we are going to increase the concentration of the hydrogen ions. And how shall we do that? Now we're not going to introduce sodium hydroxide, we will introduce an acid. So suppose now we add some hydrochloric acid to the system. So introducing this acid will provide us with more hydrogen ions, because this acid will dissociate to give us the hydrogen ions and the chloride ions. So once we add HCl to the system, then the concentration of the hydrogen ions increases, and that will affect the position of the equilibrium. So those excess hydrogen ions will therefore have to react with the bromine ions and the hypobromide ions to form both water and bromine liquid. So they will favor, that's adding HCl will favor the backward reaction, so that the excess hydrogen ions that have been introduced should react with this and lead to the production of our two substances here. So the position of the equilibrium now, this time round, will shift towards the left, because the backward reaction is being favored. And we're going to see our solution turning from colorless and we will see the yellow color intensity increasing. Our solution will start giving us more yellow color. So that's how concentration affects the position of the equilibrium. So next we're going to look at our next factor, which is temperature.